Hello guys, welcome back to the channel. So today we are in our operating system lectures. We are going to discuss about the process control block, which is also known as PCB. So today we will discuss about process control blocks and the context switching. So let's go. First of all, what is process control block? In process control block, as it name shows, it's a block. So in block there are different segments or there are different states. It's also include the counters, numbers, limits, files, registers, all in the one block. Process block mean all the things related to the process are encapsulated in the block. So what are the things that are considered in it? First of all, we have the process ID. Next we have the process state, program counter, CPU register, CPU scheduling, memory management information, accounting information, and IO status information. So let's briefly explain these. What is process ID? So when the process starts, each process has its own ID. For example, each student in the class has its own unique ID. Means each one has its own unique roll number. So in our case, in operating system, in process control block, each process has the unique ID. Next we have the process state. In which state? Is it in running state? Is it in waiting state? Is it in output device state? All the states. Next we have the program counters. What are the program counters we are using in the process control blocks? Program counters means the counting. Next we have the CPU registers. We use the CPU registers, CPU scheduling, which we discussed in our previous lecture. And memory management information means all the information related to the memory space or the memory management. Next we have the accounting information, and last but not the least we have the input output status information. So what is the status of input output information in our block? So in the on our right side we can see the graphical representation of the PCB. So in PCB, first of all we have the process state. Process ID is not mentioned in process block. It is the ID which is given on appropriate block. So first of all we have the process state, then process numbers, on which numbers or the process ID which is on the process is on going on. Next we have program counters, registers. In blue space we have registers. Next, what is the memory limit, and what are the list of open files. What is context switching? We touch a little bit of context switching in our previous lecture where we discussed the dispatch latency. So dispatch latency and context switching is a bit similar. So what is context switching? When the CPU switches to another process. Okay, when the CPU switches from one process to the other process, so the system must save the state of the old process and load the save state for the new process via context switch. Okay, let me make it simple to for you guys to easily understand it. So in context switching, CPU is when switches CPU switches from one to another state, from one to another process, sorry. So the system must save the state of the older process from previously where the CPU is on, and load the saved data, the data which is the state which it's saved from the old process. Okay, relate all these to the saved state from the for the new process. Okay, previous process, save the state of previous process, then load it into the saved process save state, and then for the new process. So it's the concept of context switching. Hope you will understand it. So context is the process which is represented in the PCB, program control block. So process control block, sorry. Okay, context switching is overhead. So the system does no useful work while switching. So the more complex of the operating system and the PCB, the longer the context switch when we have more complexities in operating system and program controller block, process controller block, then the context switches is longer.